Section 10.1. Section 10.1 and 10.2 and 10.3 deal with the sine wave and the cosine wave. The first problem you're going to see is complete the table. So they give you an equation, y equals 5 cosine x, or y equals 2 sine x, or something like that. But pretty much your calculator must be in radian mode when you're doing this. And you know it has to be in radian mode because all of the numbers they're giving you for x are in terms of pi. So on the first particular example, it says x equals minus pi. So down here, x equals minus pi. I put a minus pi in for x, so now I'm doing y equals 5 cosine minus pi. In radian mode again, the minus pi is minus 3.14. When I press the cosine button for that, I get minus 0.999. Times 5, I get a negative 5, so on the computer I type in a negative 5. The next one, x equals minus 3 pi over 4. Minus 3 pi over 4 is 3 times pi divided by 4, so that's approximately minus 2.356. So y equals 5 cosine minus 2.356. The cosine of minus 2.356 is minus 0.707 times 5 is a minus 3.54, and I put minus 3.5 in the chart. The next one, minus pi over 2. Cosine of minus pi over 2 is approximately minus 1.57, so I press the cosine button, and the cosine of pi over 2, or minus pi over 2, is 0, so 5 times 0 is 0, so I put a 0 in. Do the next one, minus pi over 4. Minus pi over 4 is approximately a minus 0.785. Press the cosine button, it's get positive 0.707 times 5, 3.5. Finally, there are more on the computer, but the next one I'm doing in the last one, I put a 0 in. Cosine of 0 is a 1. Again, I'm in radian mode. 1 times 5 is 5, and I put 5 in. Then they want you to graph it. The graph of a cosine chart looks like this. It basically starts at a peak value, which is called the amplitude, and the minus amplitude is down here, and it crosses the x-axis at pi over 2. It reaches the negative amplitude right here at pi, or 180 degrees, crosses again at 0, 3 pi over 2, or 207 degrees, and finally 1 all the way around 2 pi. So notice it's pretty much broken up into 4 quadrants, as you can see here. Each of these 4 quadrants makes up one complete cosine. So since the equation on the other page is y equals 5 cosine x, it's basically the same shape as the cosine. The only thing is it has an amplitude of 5, so I put a positive 5 and a minus 5 over here, and I draw my wave. And notice it's ending at 2 pi, one complete cycle. If you have a equation that says y equals 6 sine x, for the chart you do exactly the same thing. Your calculator's in radian mode, but this time you just press the sine button and multiply everything by 6. The basic sine graph looks like this. It starts at 0, goes up to a peak at pi over 2, crosses the axis again at pi, comes down, the negative peak is at 3 pi over 2, and finally one complete cycle is 2 pi, so from 0 to 2 pi. So for y equals 6 sine x, it basically looks like a regular sine wave ending at 2 pi, but it goes up to 6 and down to minus 6. If I had y equals minus 6 sine x, and I'm graphing that, it looks like a general sine wave curve. The only difference is it goes down before it goes up. So when you start at 0, it goes down and ends at 2 pi. Same for a cosine curve. If you have y equals a positive 1/2 sine x, again, you still have the general shape of a sine wave curve, ends at 2 pi, starts at 0, but this time the amplitude is only at a half and minus a half, as you can see from there.